We'll see you.
MA, whatever name it is. Bye. MA. MA. MI. I don't really know. From that I'm in, but
My backpack was open and you didn't tell me anything.
what?
My backpack was open and you didn't tell me anything.
You think I noticed?
Yes, you should have.
Sorry, I'll make notes and notice next time.
You know, you're being mean.
Hi, Ashley. I have a
Hey.
course conference today. It's gonna be terrible.
A little course?
A course.
You're in course? You're in course?
He's been in course since fifth grade.
I thought you were in gym. Yeah.
He's in band too.
Oh, wait, what?
I'm bringing stuff on next year. Hi, Carson.
Okay. I'm not gonna be here next year, so I really don't
What?
care.
You're gonna be here?
Yeah, I'm moving.
But where? Idaho?
Yes, definitely. Going to take Ireland, but America, definitely.
Idaho.
Oh.
Yeah, we know this information. We know this, Owen.
Yeah.
Okay, so why are you moving to Idaho or wherever you're
I'm not moving to Idaho.
Where are you moving then?
I don't know.
We're just moving to Idaho.
We're just moving, that's all I know.
Oh,
You can move 2 feet. No, that's moving.
just like.
There, I moved.
You moved. So you're still going to
Let's
go.
go there.
But this community is great. This is great.
No, it's not.
Dude, what? Because right here, I make it so great. Yeah. That's
I
exactly.
hate this town.
What do you say? You hate me?
I hate this town. I hate our culture.
I love our culture.
Ew, you're the most rude.
Yeah, it's like the best culture.
No, it's not.
Because I'm here.
No. You think the local culture is the most thing? I don't want to part of it. One of the best. Yeah, I think very good.
I know.
Are you talking about football or just like in general? Just in general. I think we're better than Grayson. What? Academically, we're better than Grayson.
Yeah, academically, yeah. And how was your health? What was your health?
Just nothing really. But, I got you to take my test, that one. Like, I'm 90.
I got 100 on the test. Because I thought I was going to get like a 0. Like, I didn't know how to do it.
I got a 90, and I was like, and my friend was like, can I retake it? Like, can you step to the test? I got to see I'm an 80. So I think. I thought I knew like, the checking one wrong. I got the one wrong about using the ATM immediately. I thought I'd like finish compression, but then use it. Yeah, I didn't do that. Yeah. It's so little. Oh, tennis lesson. I was like not home all day, and I was like driving, and so I couldn't like text you back, but we did.
Yeah, no, I love it. My mom had to go, she was so old.
It was better than like last week. Because it wasn't as, well, it was still windy, but it wasn't like,
I'm glad to know.
good.
Are you?
Yeah.
Oh, you're on friends.
Oh, and there's like a Zoom thing, so, are you gonna chat with them? There's like a Zoom thing, and I can ask you about it tomorrow.
Oh, what time?
6:30. If you go to athletics, on the rugby page, and then you go to spring ball, go to tennis, and then go to tennis page.
Is that fun?
I'm just kidding.
Yeah, mine is
It's
good morning.
pretty fun. Morning. Do you play tennis? Miss Practice.
Yes, ma'am.
You know how you like weren't here yesterday?
I do know
I
that.
still turned it into the sub, and
That's
it was
fine.
like, so it's on your desk now.
Yes.
And I turned it in yesterday, I just, you know, like,
Well, no, they were here when I got here this morning, so it wouldn't have been late.
Yeah.
So that's fine. That's
thank you.
absolutely fine. Okay. Good morning, people in the online classroom. So let's talk about where we are right now and what we've got going on today, tomorrow. So yesterday, for basically like homework, you did this performance final practice. You also, first of all, turned in your construction project. Okay, so that was important. First of all, several people's I've already gotten, several people's that I got online, I already graded. If for whatever reason you haven't gotten it into me already, just get it into me as soon as possible. Okay, I've got some people who have had certain special cases, somebody who doesn't have a compass still, that kind of thing. A couple of people have reached out to me. If for whatever reason you didn't already get it in, get it into me ASAP. And then let's go ahead and look at, let's see if I can share, and this is, okay, this is yesterday. Time to finish up your construction project, talks about how to turn it in. Then, and if you hadn't already done it and you weren't sure where to do it, I've said some people turned it in yesterday on yesterday's, like on that one. Some people turned it in on the one where it was originally assigned, which is Thursday. Either one of those is fine. If you turn it in somewhere else, you might want to make sure I saw it. Like just shoot me a quick email that says, here's where I put mine. But that was basically the first thing yesterday. The second thing yesterday is your performance final is this Wednesday. Okay, so that's why this practice performance final is attached, and that was your assignment to work on. So it looks like this. So if you already have that done, if you did it on pace, well, whatever you did it on, you can go ahead and get that out, because that's what the majority of our time today is going to be, is going over this. This is, for most, if not all of you, your first performance final of high school. This happens every semester in every math class all the way through high school. You have a performance final that's basically 5% of your overall class grade. It's kind of like your whole final exam is 20% of the grade. The multiple choice part that you take on exam day is 15% of the grade. The performance final is 5% of the grade. So it's like 3/4 of your final happens on exam day and it's multiple choice. 1/4 of your final is this, your performance final. It happens tomorrow. And there are going to be multiple ways you can do this. It's going to be on eClass where you can type out your answer, but quite frankly, I think that's very likely the hardest way to do it. I think the easiest way to do it is on either print this out, print out your, not this one, but the performance final that you get tomorrow, either print out the performance final itself and do it on that paper, or just on any other paper. Just answer it, because that way, a lot of times, part of your answer wants to be like drawing a picture or labeling a picture or doing something visual, which would be hard to do in type. So I would expect that probably the minority of responses that I get are going to be just typed into eClass. And if you do choose to do that, make sure you're being very descriptive in terms of what picture you're talking about and that kind of thing. But like for me, one of the very first things I would do for this particular problem is start labeling things so that we can talk about it. Because if you don't have the visual, it's hard to describe what part of the whole image you're talking about. Okay, so what I wanted to do, since, like I said, performance finals are going to be part of every math class you take in high school, is go ahead and just go through this with you. This example, this is the practice one from yesterday. It's not for a grade. It's just so that you could go ahead and practice and see how well what you got matches what I would want you to get. Question?
Do you have like a copy of that?
I don't. Nope, I don't have any. I've just got the digital. Okay, so you can write it on paper. You don't really need this at all. You're absolutely welcome to write it on paper because there's very little to draw. It's mostly stuff you would have to write yourself anyway. If I was doing this on this paper, and I'm pointing at this, but it's not on the screen yet. The first thing I would do is probably label it, but that's really the only thing that it would help to have this for. So let me just go ahead and get attendance of our online folks, and then we will jump right into that. So that's what we're doing tomorrow is the performance final. Also, you notice I posted a Delta Math final exam review. That's the first of probably several final exam reviews, because after the performance final tomorrow, that's all we've got left is just reviewing for the final. Your final exam in here, the multiple choice final exam, which is 15% of your overall course grade, is 1 week from tomorrow. It's Wednesday, December 16th. Okay, so basically after tomorrow, that's all we've got left is to review for that. And it goes back through the entire semester. So that's why we're doing a lot of review. Okay. One other thing that I feel led to mention, we were just talking about in the hall, is you guys have probably noticed that there seems to be an uptick in numbers of cases, that there seems to be more COVID going around right now. And they've talked about why that is and what, like I've seen stuff in the news about how it's probably because it's cold and people are more inside and around each other, close quarters, that kind of thing. I just want to encourage you to make sure that you're being careful. And that, like, I came back today to a few emails of people who are staying home because they think they might have been exposed, and so they're checking. But, you know, make sure you're monitoring your symptoms. And if you hear that you've been potentially exposed, make sure you are careful about that. And also maintain your social distance from everybody for their benefit and your benefit, for everybody's benefit. Okay. So please, as we get into this, the county is clearly concerned that we are being as careful as possible because they're talking about giving us medical grade masks for teachers at this point. So I think everybody's concerned about, as we get into winter, just how much the spread's going to happen and trying to keep it minimized. So just be aware, you know, the same stuff you've been doing, just sort of, what's the word? Rededicate your efforts. Don't get too relaxed. It tends to get very, been there, done that after a while, but now is not the time to fall down on the job. Okay, so let's see. Jaden here? I don't see Jaden. And I do not see Samira. Okay. This document camera is always so weird. I always have to close it and then reopen it and close it and reopen it. Okay, here we go. Okay, it says a tree with a height of 4 meters casts a shadow 15 meters long on the ground. Label the diagram. So I'm going to say this is my tree with a height of 4 meters. So I'm going to label that. And it casts a shadow 15 meters on the ground. The first question asks, how high is another tree, so over here, that casts a shadow which is 20 meters long? Round your answer to the nearest tenth. So we're looking for this number right here. We're looking for the height. Now, if it's the same time of day, which is what's implied here, then these have to be similar triangles because these angles have to be the same. This angle right here has to be the same because the sun is in the same spot for both of them. So the angles would be the same. So we have similar triangles because this is like a right angle. And then we have another angle. So I would say, I would explain that. I would say by angle, the two right triangles are similar. Okay. So we can set up a proportion. So basically you're answering, but also making sure that it's very clear everything that you're doing in your answer, everything that you're doing as part of your answer. Like, why are you answering this? One way that I've sometimes described performance final exams to my students is it's kind of like you're tutoring your friend in Alaska, but they don't have Wi-Fi. You have to tutor them via pen pal, like in the mail. Like they send you a problem and you're like, okay, let me explain to you how to do this problem, but you have to do it in writing. They don't have phones either. Alaska does have these things. I'm just saying. Maybe they're in the Arctic. I don't know. So we can set up a proportion to find the missing side. So my proportion would be 4 over h equals 15 over 20. And that's not the only way you could set it up. You could say 4 over 15 equals h over 20. So then I cross multiply. So then 20 times 4 equals 15 times h. And I'll solve it. I don't really have to explain every step of solving because we know how to solve equations. Okay, so that's 1, 2, 3, 4, 5. This goes 5 and 1/3. What was that? Yeah, 5 and 1/3 times. So the height is about 5. We can do it to decimals. Meters, 5.3 meters, or 5 and 1/3 meters. So that's the easiest way to do the first one, is not to necessarily use any trig, any sine, cosine, tangent, just to use similar triangles. Yes, ma'am. Either one is fine, yeah. That's one of the nice things about performance finals is how to write your answers is kind of up to you. I would personally probably choose to be most complete to do it like both ways. You know, like basically I would do something like what I just did. Okay. But there's not necessarily a wrong way to do anything that you're doing in a performance funnel. One of the things we need to talk about today is the rubric for performance funnels. So let's finish this one and we'll come back and talk about that. Okay, what is the value of theta, the measure of the angle of elevation to the sun? So that's right here and right here. Round your answer to the nearest degree. Okay, so I would probably do something like maybe redraw. It doesn't really matter which one I use, but I'm going to use the one that already had sides given. I would redraw this so that I can point out that this is the opposite side and this is the adjacent side. Okay, so tangent of theta equals opposite over adjacent. So that means that theta is the inverse tangent of 4/15. And then I'm going to go ahead and put that in my calculator. Inverse tan 4/15. Remember, this is the time we use inverse. It's the only time we use inverse is when we're finding a missing angle. So theta is, I'm going to do this, or about 15 degrees. Now, I didn't really say much explanation. I would accept that for full credit, but you could maybe say, in terms of explanation, maybe you would want to say, because 4 is opposite and 15 is adjacent to theta, we use tangent or something like that. We use, that's not how we say use, sorry, use tangent. Maybe you might want to start with something like that in terms of explanation. Okay. Or you might want to say we use the inverse because we're trying to find a missing angle. Those are things you could say for explanation. But if you're showing your work real well there, I would gather that you understand that. Okay. Further clarification, when I talk to students about what, just things, how to do a performance final, when you explain it, you don't necessarily want to explain it like you're explaining it to me, because, and then in the way in which I mean that is, don't assume you're explaining it to someone who already understands it. Okay, you're explaining it to someone who's struggling with this. So like maybe that would be necessary to help them understand why you use tangent here. Yes, ma'am. Yes, you don't have to write in complete sentences. They're not wrong though. Complete sentences are kind of nice. You definitely don't have to do like paragraphs or anything like that. Okay, but anything that helps explain it, anything you would use to help somebody explain it in writing, which includes maybe little diagrams or visuals, writing equations, just being as clear as you can about what happens first and then what happens next, things like that. Okay. All right, so how the rubric works, and I thought I had one printed out for you, but I don't think I do. The rubric has 3 parts. And in each of the 3 parts, you basically are scored between a 1 and a 6. Okay, and then we have a thing that translates it, like an 18 would be 100. So, and then like a 17 out of 18 would be like, I don't know, like a 96 or something like that. But we have like a There's a word for it, and I can't think of it right now. But we have a way to get from, this is a total of 18 points to numeric grades. So I'll put it in a numeric grade for you. I won't just put 18 or whatever. So first off, the main thing I always want students to see when it comes to the rubric is actually doing the math correctly. That's really only 1/3 of your grade. You could do the whole problem wrong and still get more than half credit. Okay, that's another thing that's beautiful about performance final. It's like the ultimate partial credit. Is even if you don't know how to start the problem, if you just say some things that you know about related stuff, that's going to get you some credit. Anything you show me that you know is going to get you some credit. Okay? If you get the problem right and tell me the way you got it right, that's your reasoning and your problem solving. The reason, this is basically explaining your thinking. And you do a good job of explaining your thinking, then yeah, that's full credit. But let's say you get it all right and you just do a horrible job of explaining your thinking. That's still going to be mostly credit. Let's say you get it wrong, but you do a really good job of explaining what you did to get that and why you think that. That's going to still get you most credit. Okay? So there's a lot of opportunity to get a lot of credit, even if you mess something up. So keep that in mind. All right? These two, I will say, these two are very closely tied. Because I can't grade you on your thinking if you don't communicate it well to me. You got to tell me what you're thinking or why did you do this? For me to be able to say, okay, they showed good thinking and problem solving somewhere in here. Okay, they showed reasonable, they came up with good reasoning about why they did that. Even if it was wrong to do that, they showed me their reasoning and that was some valid reasoning. I can see why you would think it's like this type of problem or something like that. Okay. So it's really important. Communication becomes really important because if you can't, and really these are linked too. If you don't show me what you're thinking and what you're doing, I can't grade it high. I can't give you the credit for the fact that your thinking makes sense or your problem solving seems reasonable. Or yes, it's clear that they know a lot about this subject. You have to have that communication for me to see those. Okay, so that's what these are based on. Okay, so like the answer I just gave you for this, like let's say it's hard to get a perfect score because a perfect score means basically you described everything that anybody would ever want to know about this. So maybe like, especially without this, maybe this would be a 17 out of 18. But there's a lot of other ways to get a 17 out of 18 or an 18 out of 18. There's a lot of different ways, like your answer doesn't have to look exactly like mine to still get that. Let's say I got the proportion totally wrong. And so I got the wrong answer here. But I still explained everything the same way I did here. That might be like a 15 out of 18. Something like that. Okay, so let's go ahead and do a couple more. Topic 2, congruent triangles. Use the figure to the right for 2A through 2C. If triangle DEF is a translation of ABC, so that means this is the start and this is the finish. That's what I might do to help myself there. Then what is true about the various sides and angles of these two triangles? Specifically, which parts of these two triangles are related and how are they related? Why? Okay, so what I'm thinking about is this. A translation is an isometry. This is basically what they're asking you to get at, which means, were you raising your hand? Okay, which means that it preserves or keeps everything about size. This means triangle ABC is congruent to triangle DEF. Now, it says specifically what parts, so I'm going to go ahead and explain that a little further. So, and I'm just going to basically say all the things that it means are congruent. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. Okay? When you think you're finished, go back and reread the question and make sure you've hit everything. It says, what is true about the various sides and angles? Key word here is congruent. So I definitely use that key word, and I might even write that. Another way you could have said it, you could have said a translation's an isometry, which means that the two figures are congruent. That would get you just as much credit. You could have said this is a translation is a rigid transformation, so the two figures are congruent. Remember, we called it rigid transformation or isometry. If you can't remember that word, you're still going to get most, if not all, credit for just saying that the two, you know, when you do a translation, the size stays the same, even if you can't remember the word isometry. You get a little bit more credit for getting the word isometry. That might be a difference between, you know, in terms of content, 6 out of 6 versus 5 out of 6, because vocab is important. Okay. Specifically what parts. So this is my specifically what parts are related and how are they related? They're all congruent. I said that. Why? Because it's an isometry. So I've pretty much covered it all. Now I'm ready to go on to 2B. Are these triangles congruent? Why or why not? Okay, I think the easiest way to answer them, don't go down the rabbit hole. This is the fact that this question came first should help me not go down the rabbit hole of trying to find distance formula for all of these. That's one way to do it, is you could find all the lengths. That's not the most efficient way to do it. The most efficient way to do it is to say that they're a reflection of each other across the y-axis. And because reflections are isometries, that makes it congruent. Okay, so I would probably just, I don't know. I would consider pointing out that I know that they're reflections by looking at how the coordinates change. Okay. Like, and this is one reason why very often I encourage students to use extra paper if they want to. And this is, again, why it's okay if you don't have it printed out. That's fine. I might say, let me just take the coordinates. What is this? 1, 2, -2, 6 is what L is. And then C is at 2, 6. M is at -1, -2, -3, -4, 5, 6, 7, -7, 3. And that goes to B, which is at 1, 2, 3, 4, 5, 6, 7, just confirming. 3. K is at -1, 3. And A is at 1, 3. So I would say this is a reflection across the y-axis, and maybe point out how I know that is that all the X signs have changed. So it is an isometry, or you could say rigid transformation, which means the size does not change. And notice it said, are they congruent? So I need to confirm that at some point. MLK is congruent to BCA. Remember, order matters. M goes with B, L goes with C, K goes with A. I could have said KLM, but this is not the only way to write, the only right way to answer this. Okay. You could have used distance formula and found all the distances and then explained that because all the side lengths were the same. But if you did that, you would need to say, if all the side length is the same, then side, side, side tells me the triangles are congruent. Okay. It's just that because it's a reflection, that's another way I can tell you they're congruent because that's isometries. All right, 2C, are these triangles congruent? Why or why not? Same thing. I'm not going to go back through the whole thing. Basically, this is a no. No. And you know what? If I were trying to show that those aren't congruent, I would either point out that to translate one to the other, like it looks like it should be a translation if they were congruent. If I translated one onto the other, then if I translated Z onto A, then Y would be right here. It would not be where C is. That would be one way to say they're not congruent. Another way is I could just find the length of YZ, like use the distance formula. The length of YZ is going to be square root of 5. And the length of AC is going to be square root of 10. So YZ is not congruent to AC or something like that. You could talk about that way. All right, last question on this page. And I would say more here. I'm just not saying more right now because I already said pretty much did an example just like that for 2B. And we got more to get to. Okay, for 2D, what sequence of rigid motions? Rigid motions means isometries. It's the same thing as rigid transformation. Maps DGL onto CMB. So we're going from this to that. Okay. I would say the easiest way to me would be to reflect it across the y-axis and then move it down. So let's see if that works. Reflecting it across the y-axis. So I'm going to start with G is at -4, 7. L is at -4, 2. And D is at -6, 2. So I'm going to say that reflects across the y-axis to become, and first I'm going to look here and see what that would become so I can confirm over here. That would be, let's say G prime. When you go across the y-axis, the sign of X changes. So this would be 4, 7, 4, 2, and 6, 2. So then I would go ahead and I would graph that. 4, 7, 4, 2, and something seems wrong here. I misrepresented D. D is at -7, 2. So that would be right there. So that would be at 7, 2. Okay. And then I can translate straight down. X is not going to change, so I'm going down only. Y minus, so I'm going to go down 1, 2, 3, 4, 5, 6, 7 to get N is at what? 4, 0. B is at 4, -5, and C is at excuse me, 7, -5. coughing fit, sorry. It's hard to teach and not be able to drink, so sorry about that. I'm all dried out. After our early conversation, you'll be happy to know I have no other symptoms. Just having a coffee. Okay. So that's our second example. This one I've already mostly done. So let me just show you what I've done so far. I went ahead and labeled these because you have to be able to know that this is 3 and this is 4, 5, 6, this is 7. So this is angle 3. Angle 7. And I'm going to let you guys look at that while I step out and get a drink of water real quick. Okay. One of the things I wanted to point out about this one is it says state the relationship between these angle pairs. It's a little ambiguous. Do you mean these kind of relationships? Or do you mean congruent and supplementary? I would include both because of that. Because I'm not sure what's being asked, I'm going to tell both. So you want to err on the side of more information, not less. Okay. So we said if M and N are parallel, then these two would be equal since corresponding angles would be congruent. That means X equals 38. But then these two have to be supplementary because they're a linear pair. Sorry, these two. So that's what I said here. And when you do that, you don't get X is 38. So therefore, we know that these are not parallel because those angles can't be congruent. X can't be 38 because it has to equal 23. These two have to be a linear pair. These two don't necessarily have to be congruent. So if these two make 180, then X is 23, and that would not give me 45 and 45 here. That would give me 30 and 45 here, so those aren't congruent. And there's multiple ways you could explain that. This part is really straightforward, except that you're not sure which one to use, so do both. Then state the relationship between angles 3 and 5. Okay, so up here we said this is 3, this is 5. So three and 5. I don't understand why what this is asking, but let's suppose you get a question you don't really understand. So angle 3 and angle 5, you can still show that you know what you're doing, whether the question makes sense or not, honestly, are same side interior angles. Remember, we also call those not corresponding, consecutive interior angles. So you could have said that. Would this information, what information, be enough to prove that they are parallel? Well, we don't really have any information about those except for, we don't have any information about 5. Okay, so I would say in order to prove M is parallel to N, I would have to know that the measure of angle 5 is equal to x plus 7, or another way to put that is that measure 5 is congruent to angle 5 is congruent to angle 3. I would probably just add that I don't have that. I don't know that. So at this point, we don't know that. So if you don't think you have enough information, basically explain why you don't have enough information. Anything that's part of showing your thinking, your reasoning, and your problem solving. Isabel?
For the first problem that we did,
Here?
we also use like the tangent and on the first piece. To find the missing thread.
I did use the tangent, didn't I? Oh,
on the-
no, because, well, yes, you could. But the problem is, I actually started to do that the first time I did that. It's easier to use similar triangles to use the tangent. First off, you'd have to say that they're similar, so these angles are the same. Okay. Then you have to find this angle over here by doing the inverse tangent, and then you come over here and set up an equation with the tangent. But you could do it. I just think it's a little bit longer, but that's okay. If that's the way you see it, then go for it. Yeah. Just make sure you explain what you're doing. All right, last problem. A rigid motion is a motion that preserves size, are the key words here. The 3 types of rigid motions are rotations, reflections, and translations. Plot the image of the triangle after the transformation 3x, 3y. Well, we should know from looking at that that's going to be a what? When you multiply your coordinates by something, you're doing a what? So the D, dilation, yeah. So let me go ahead and plot this. I would probably go ahead and write out I want to be very transparent about what I'm doing and what I'm thinking. So -2, 1, 2, 3, 4. B is at 1, 2, 3, 1, 2, 3. C is at -2, 1. So that's going to become -6, 12, 9, 9, -6, 3. And now I'm going to go ahead and graph it. 1, 2, 3, 6, 1, 11, 12 is going to be way up here somewhere. 9, 9. You're right there. And -6, 3. It'll be right here. Whoa, I'm sorry. That should be over 1. I went too far. That's why you use pencil and not pen. It's easier to see pen on this thing. Okay, this is a dilation. Which does not preserve size. I'm going to go ahead and say that ABC is not congruent to A prime, B prime, C prime. I'm basically saying the same thing different ways. So it is not a rigid motion. Plot the image after the transformation negative negative xy. Is the transformation a rigid motion? We should know that this, remember, it's actually a reflection across the y-axis. Remember, when you reflect across the y-axis, it changes the sign of x. That's the only thing that changes, is the sign of x. Okay, but we can go ahead and do that. We need to do it with coordinates. Same figure, so I'm going to borrow the coordinates from up here. Changing the sign of x. A prime, B prime, C prime. 2, 4, 2, 1, and negative 3, 3. This is a reflection. This is a reflection across the y-axis. The triangles are congruent. And it is a rigid motion. Okay, so something like that. So this is the kind of thing you're going to do tomorrow on your performance final. Just do the best you can to explain it. You've got the whole period. You'll have like 2 of them to do. Do not overly stress, because they really are easier than like a multiple choice or a short answer test, because I can give you all kinds of a partial credit. Okay, like I can give you far more partial credit than usual. It's not like it's half off or something like that. No, I can give you most of the credit even if you get some things wrong. So keep that in mind. Just explain your thinking really well. And it's 5% of your grade, which it's important. It's enough to be important, but it's a little bit less than a test grade. Okay, so just keep that in mind. It's not like it's going to be bigger than any test or anything like that. Okay. Any questions on that before we say adieu? Adieu, adieu to you and you and you. Remember that from Sound of Music. Before you guys go, let me just make sure I don't see Jaden or Samira. Nope, I do not. Okay, well, I will see you guys tomorrow, or I won't see you, but, well, you do need to log in. We're going to do it kind of like a test. So you do need to log into the Google Meets room while you're doing this. Okay, so I guess I will see you. So see you later. If I can manage to hang up.